So we've been talking a lot about the simulation software here, and I'm not going to go on for great length on that, but I wanted to show you an initiative together with ESBO providing simulation software which is both reliable and not so difficult to use. It's never trivial to use any kind of model, but it also allows you to put real products of shading and glazing and other HVAC products as well into real buildings, real building models, and that's the important thing. And one unique feature is that we do spectral calculations. We resolve the wavelengths for both the shading and the glazing, and this has become very, very important lately, and I want to discuss that some more. We have this es-sda quality label on the data that David just talked about. So companies in the database can put up that label. And a nice thing is that there's the free version of it from the es-sda website. This link is not quite live yet, but the tool that I will be showing you today is the beta version of this es-sda tool, and it will be posted on the website within a week or two, when you're back from the trade show, probably. ESBO is the first step of a ladder of products, and it's an easy to use, free version. There's also a paid version of ESBO, which is equally simple. You will immediately recognize your way around it if you know the light version. It allows you to do some things that you cannot do in the light version, of course. Then there's also our sort of flagship products, which are the kind of tools that people spend every day on modeling buildings, and your products will be in those tools as well. So our es-sda is the leading software product, building simulation product in Northern Europe, German-speaking part of the world, and the Nordics. So there'll be a lot of professional people using your products or being able to select your products every day. I want to stress this thing with spectral. Why is it so important? It's important when you have more than one spectrally selective layer in your construction. Then you actually need to do spectral modeling of both the shading and the glazing in order to get the right results. And just an example, if you have a modern glazing, a modern internal screen, so this is an internal shading, and you model this in a non-spectral way, then you get a good G value, you get reasonable shading plus glazing G value, reduction of the solar heating by the shading by 43%. But if I do this spectrally, I get quite different numbers. And instead of reducing the solar shading by 43%, it will reduce it by 60%, which is obviously quite significant for practical applications. So there are many cases where you can use internal shading where you couldn't otherwise in this. So these errors can become very significant. So when you discuss simulation in various contexts, make sure that you can take your product data and get it into the simulation program in a spectral fashion, and you can do that for both the shading and the glazing. There's not that many simulation programs that you can do that in. es-sda is one of them, but there are others. And so let me venture a little bit of a demonstration here. How are we doing for time, Andrew? So this is the portal page that meets you when you have installed this es-sda Lite from the es-sda web page. You can select your language. It's available in 8 languages. There are some start cases. There will be more, but there's a few there to start from. And also the officials of es-sda can actually talk to their members here. So each time somebody opens this program, you can give them a message. The news is here available for es-sda to publish whenever they want to this group of people. There's some supporting things like manuals and forums and links and things like that. Let's start to look at a simple case. Now, let's see. So the first, this is because of the internet here at the trade fair. I'm happy that it works at all. So this is the first page that meets the user, and if you're only interested in the shading and the glazing performance, it's quite simple. You just select a glazing from either from the preloaded glazings or from a database of a lot of different glazing combinations. And then you select what sort of shading you want to look at. So for example, I will use an exterior screen. You can see here on the picture that there is an exterior screen, and I open this. This is and then I open that exterior screen assembly, and I will select some fabric, and this is the ESBO or the database of fabrics that are in the program, and these fabrics are uploaded by the manufacturers themselves. So it's not like we collect all of the data and you have to wait for months before it's published. You just press the button and it's here within an hour. And that we did yesterday, actually, because we have just gotten the first es-sda approved labeled products into the database. So here are some examples, and of course we will select one of those for our study. And then, so having selected the glazing, having selected the shading, I can now just do a very quick evaluation and get the key numbers. This report we will make nicer looking, but at least you get the key values with and without the shading here in a spectral, trustworthy way. But that's not enough. I know that's enough for a lot of people, and we want to provide that. But you can also look at how will this shading behave in the context of a room and in the context of a building. So that's where all of the other data comes in. We have to select a location. I'm not going to use the internet, so I've safely, actually this is the internet, but I'm still not going to use that. I'll use this one that I downloaded before. So this is climate data for Munich. It's both an extremely hot days and extremely cold days, and also a measured whole year weather file. So, and then there's some, while I simulate, I'll explain some other things. So now you can look at some different cases here. I'm looking at a cooling design case, just checking how much cooling do we need in this room. You can run it without cooling also and look at overheating, see how hot it gets, or you can look at a winter case and see how much heating you need to heat the room. And in order to do this, you need to provide the thermal loads, how many people are there, and the operation, when are you running fans and things like that. So there is some extra data you need, but only what you see here. So it's not more. You can make a meaningful series calculation with this data. And then you get a report with the ESBO logo on it, of course, where you can look at some of the details from the simulation. For example, how did the shading move over the year and so on, or over the day. So that's the first level of the free ESBO. There's another more general level as well, where you can do a lot of more things to the room. Some of them you might be interested in. For example, adding another window. So you can add another window, and you can look at wall constructions and HVAC systems in a lot of detail and things like that. Also in the free version. Right. So one thing that we talked about, or that is of paramount interest, of course, is the control strategy. So you need a lot of things. You need good glazing data, you need good shading data, but you also need to know how to control this. And in ESBO, there's a range of control schemes already available. We can add more control schemes there very easily. There's a help function, so you can push anywhere in the program and get some help. And right now I was interested in what do these control schemes do, and here's a write-up about what the different control schemes do. I'll come back to that in a moment if I still have some more time. So there are 3 types of basic studies, or 4 actually, that you can look at with the tool. One is, I've mentioned them already, but you can do the heating design, that's a winter case. cooling design, which means that you look at every month of the year, not just the summer, but every month of the year, because rooms may peak in September and November and December and so on, depending on the orientation and the internal loads and the glazing and all that. And then you can do an energy simulation over the year. That takes about a minute, so I'm not going to do that here, but I've done it already, and we can look at the report, just to give you a quick browse of what a report looks like. For if you've done all of these simulations, this is a combined report. So you get information about the monthly cooling required for this room, or the building actually, monthly heating, temperatures over the year, weekly averages. You get, this is unoccupied time, less important. And then you get the cooling design that we already looked like. You get an account of each of the windows, what are the sort of ISO 15099 properties. We will also add this new ISO standard there very soon. And also what the real G value is under realistic conditions. And this is how the G value varies over the year as well. Many people think the G values is constant, but it's not. And this is done for each window, so you can look at the performance of those windows and the shading control signals. Right, so we're not going to go into all of the details, but I hope that I've shown you that this is probably something that you can use. Do I have a few more minutes? Or? Yeah. So I just want to show you what happens if you move up the ladder. Not that. I've seen enough of that. To look at, I'm not going to show you in detail the detailed tools, but you can, from ESBO, you can bring the model that you're working on into the full IDIs if you want, and there you can do a lot of fun things. For example, to look in detail at this is, I'll show you this later. This control scheme that we talked about. Of course, it's good to have a big range of control schemes to look at, but there will always be a twist. You know, there will nearly always in a project be some special thing that doesn't fit into this pre-listed set of control schemes. So in the full tool, you can build your own control scheme quite easily. It's not complicated at all. A lot of users do this. Of course, it's not so easy to formulate a good control algorithm, but it's possible, and you don't need to do any programming. You just do it. And this is the algorithm. Before I ruined it here, was the algorithm that was one of the predefined ones for ESBO. In the full tool, you can also do things like visualize how the shading moves, for example. Sorry. So now in this case, it's a sort of an artificial algorithm which tries to keep the lux level constant in the rooms. Not too realistic perhaps, but it shows you that you can play with algorithms and look at what it's going to look like on the building. You can also look at, for example, how the surrounding, in this particular case I don't have any surrounding buildings, but it can be useful to look at how the shades of the whole site will fall, including surrounding buildings that you can import from SketchUp and so on, or Google Maps, and then look at how will your shadings operate in that context. So, and as I mentioned already, also in this full tool, you will have access to real product data from yourselves. Okay, thank you very much.